Hello all, good morning. Welcome to this Docker second session. So yesterday we have just seen a brief idea about what exactly is this Docker and how was the things before Docker and which all functionality and benefits Docker provide to us. And along with that we just got a superficial idea about like what are the Docker images, what is the container and where those images are present. Like Docker Hub is one of the repository where all the images are present. Okay, so and about along with that we have installed the Docker on our system. Okay, so that is the one thing. And as I told you yesterday, like this container is nothing but a lightweight virtual machine. So this lightweight virtual machine and this one virtual machine, you can see there is a developer virtual machine, testing virtual machine. So there is kind of small difference between a virtual machine and container. So it's not a big difference, but there is such a there's a thin line between that virtual machine and a container, which we definitely need to understand. So for that matter, what I will do, I'll just explain some this difference with the help of some diagram. Let's say if I talk about virtual machine versus Docker, and let's go to the images. So the very first image we have this. Okay, so let's get this image on our paint so that we can just play with this. Okay, sorry, just a moment. Let me remove this. Okay, so you can see on the left hand side this is the virtual machine, and on the right hand side this is the container related thing. Okay, so there is a gap between this left hand side. Okay, this is the left side and this is the right side. Okay, this is the architecture of the virtual machine. Left side is the architecture of the virtual machine and right side is the architecture of the container. Okay, now let's consider this is my Windows laptop, and Windows laptop will have certain hardware like 1 TB of the disk, then let's say 8 GB of the RAM and 4 CPU or 8 CPU depending upon your laptop configuration. Okay, so that is nothing but our hardware configuration, right? Means storage kitna hai, RAM kitna hai, CPU kitna hai, that is nothing but a hardware configuration of our laptop. And on top of that laptop I can create a virtual machine of Ubuntu or Red Hat or CentOS, any kind of operating system. So if you want to go ahead and create in that way, then you have to install some virtual box tool provided by the Oracle, and on top of that you can create any virtual machine of any operating system. Okay, so in this case what is happening, this infrastructure the this infrastructure over here, let's consider this is belongs to the Windows operating system, and this Windows operating system will have certain resources, and out of that and if you want to create any virtual machine, we need to enable the virtualization within our laptop. That is an internal setting. Okay, and once you install that virtualization and install that virtual box provided by the Oracle, then it will be very easy for us to create a virtual machine. So one virtual machine consists of like within that virtual machine we can have the application, we can have all the binaries and libraries which are required to run that application, and guest operating system. Okay, what is the difference, but means why we call this as a guest operating system? Okay, because this infrastructure, okay, this infrastructure layer itself will have an operating system, that is nothing but I have Windows operating system. So this kind of infrastructure having an operating system, we call it as a host operating system. Okay, and on top of this Windows we are installing the other operating system. Okay, so those will be guest operating system. So the main operating system that we are having, we call it as a host operating system, and on top of that, any operating system you install, that will always be called as a guest operating system. So the entire infrastructure of this entire virtual machine will have these three parts. One is application installed within that, can be any application, uh, and the supporting binaries or supporting or dependencies, libraries, all those things which are required to run that application should also be there. Otherwise, application will not run, right? And that along with that, we will be having a operating system. We can create a Linux machine of Ubuntu operating system. We can create a Linux machine of Red Hat operating system. So this is the one virtual machine. This is the second virtual machine, and this is the third virtual machine over here. Okay, so this is nothing but an architecture की फिजिकल हार्डवेयर होता है, उसके ऊपर वर्चुअलाइजेशन इंस्टॉल करते हैं, on top of that we have to create a virtual machine. Okay, but in case of this container will also have the infrastructure. So over here we mainly prefer the Linux infrastructure. Okay, we will not have I want to say a Windows operating system. A container also work with Windows operating system, but it's very rare. Companies are not using containers over the Windows operating system. Companies are mainly preferring containers to be created over the Linux only, because there are many benefits of having Linux rather than Windows. We will talk about it. So this is our Linux operate. This is our the infrastructure of the you can say hardware. Then this is the Linux operating system. On top of that, we have and container engines. So there are many ways, or there are many other tools which provides or offers a facility to create a container. So Docker is one of them. Like with the help of Docker, we can create a container. So we have installed Docker at this layer. Okay. So we have the hardware. Okay. Hardware you meant to say. Let me show you practically. Just by going to the DigitalOcean. Okay, so we have this one machine we have created. Okay, so this is nothing but a hardware you can consider right now for us, and on top of that we have a Ubuntu operating system. Okay, so this is the hardware. We have Ubuntu operating system, and on top of this virtual machine we have installed the Docker at this stage. Okay, and once you install Docker, then you can create as many container as you want. So container will only have two things. One is like application, binaries, and libraries. This is the one container, this is second container, and this is the third container. Okay, now there is no operating system involved within the container. Okay, why so? Because container will always make use of the host operating system. All these applications will run only on a single operating system, that is nothing but a operating system which is provided by the infrastructure. So this operating system is the Ubuntu one. Okay, because we have created a virtual machine of the Ubuntu system. That's where each and every container will execute or will get created on this Ubuntu operating system. Now why we are not adding operating system within the container, and why we are adding operating system in case of virtual machine? So in case of the virtual machine, earlier days, where each and every application we used to install over the virtual machine, there are certain drawbacks of using that which are overcome by the container. Which all drawbacks? Definitely, let's say this infrastructure is of, let's say, 8 GB. Okay, and on top of that 8 GB, let's say you create a three virtual machine, each of, let's say, 2 GB. Let's say this is the 2 GB RAM allocated to this, and 2 GB RAM allocated to this, and similarly 2 GB over here. So this almost out of 8 GB, 6 GB RAM is allocated to this. So this infrastructure will have only 2 GB left with it. Okay. So in that case, this infrastructure may run little bit slow because of this shortage of the RAM. One more thing, this virtual machine is having 2 GB of the RAM, and let's consider this uh, uh, a small application is installed or running over this virtual machine which is taking almost zero point 0.1 or zero point 0.2 GB. Okay, not more than that. So there is a wastage of resource I can see over here because इस मशीन को 2 GB allocate तो कर दिया है, but application जो चल रहा है इसके अंदर that is consuming a 10% of that 2 GB. So the 90% is getting wasted or that is not getting consumed in case of the virtual machine. So that's one of the resource crunch issue, or that's one of the problem we can see, that even though we have available resources but those available resources are not getting consumed properly, and because of that we can call it as a wastage of resource. One is this. Second drawback of using the virtual machine is like, let's say if you add the guest operating system within this virtual machine, in that case the startup and the stop process will take a lot of time, because if you start the virtual machine initially, first operating system will get started which will take almost 3 to 4 minutes, and once that operating system will be done with startup, and post that application will start. So almost 3 to 4 minutes or around 5 minutes it is required in case of virtual machine to start a virtual machine, and if you want to stop the same thing again 3 to 4 minutes will be required to stop a virtual machine. So over here I can see extra time is required for restart purpose. Okay, and if you talk about the same thing over here in case of the container, as this container is not having any operating system, so in that case startup and like a starting and stopping of any application or any container will be very easy, because in case of the container we just have to start the container. That container is not having any operating system, so it will get started very quickly. Same is case of if you want to stop it, and this the container will get stopped very quickly. We will see in that practical how quick startup and stop process is that. Second is like, if we talk about the resource crunch in the virtual machine, that resource crunch is solved by this container. How? Let's say this is having the 8 GB of this RAM allocated to this allocated to this virtual machine. Then if you want to host any application within that, and if you don't define any hardware limit to this container, in that case that container will take only the required RAM. Let's say if this application required only zero point 0.1 of 0.1 GB internally, then this application or this container will take only 0.1 GB out of 8 GB. It will not consume 2 GB in case of the virtual machine. It will just consume the required RAM. Okay, it's not that is how, like, whatever the required resources, I mean to say, the container required any kind of resources, only that container will take the minimal of it. It will not consume, it will not keep the almost 2 GB or 3 GB with container and use only 10%. It is not like that. So that's where we don't have to worry about like wastage of the resources in case of container. You will see all those things in practical as well, but just wanted to share the glimpse of uh, the difference between a virtual machine, means installing an application over the virtual machine versus installing an application over the container. And plus one more benefit is like, it's very easy to share the application with anyone within your team with the help of container. Okay, in case of virtual machine we have to copy an entire application to another virtual machine and copy all the libraries and binaries to another virtual machine. So a lot of manual steps are involved within that in case of the virtual machine if you want to replicate any application. But in case of container it's very easy to share our application with anyone within your team. Okay, so these are some uh, plus points in case of the container of, if we compare it with the virtual machine. Understood this much? At least a brief idea about a difference. Okay, so we can just shift to the practical so that things will be much more easier for us to understand. So let me log into this machine. Okay, so Docker, we have already installed Docker at our end yesterday. Docker version. Then if you want to see the status of the Docker, means the Docker process is up and running or not. You can check it via systemctl status and name of the process. Okay, so Docker is the name of the process over here. So currently it is active and running. Okay, in some operating system, once the installation is completed, it goes into the inactive state. So you have to just start it with the help of systemctl start Docker. But on the Ubuntu one, it gets started automatically once you install it. So in our case, we don't have to start it because it is already started. And along with that, now we will just learn about certain Docker related commands. Okay, so as I told you that we have to create a image, sorry, we have to download an image. So, and where is the image repository? That is nothing but a Docker Hub. Okay, Docker Hub is a image repository where you can see all the images. So let's search with Nginx over here, because Nginx is very basic image to start with. It is one of the web application development tool where we can develop all our websites and host it over the server. Now this is the Docker official image, so we are going to download this image at our end. So how to download and all those things that you will get to know just by going into this Nginx documentation. So you will see Docker pull Nginx. Pull is nothing but download it at our end. So this is the command which we will be using to download this Nginx image on our Ubuntu system. Okay, so let's see this Docker image ls. Okay, this Docker image ls is going to show us which all images are downloaded already on my system. As of now, there is nothing I can see over here, so it means I don't have any image downloaded on my local system or the Ubuntu system over here. So let's download it with the help of pull. Any command you want to play with image. Okay, the thing is, just understand one thing over here. Any command that we are playing with, like pulling an image, removing an image, or creating an image, all those things will start with Docker image. Means Docker is the command line tool which will come by default. If you want to play with images, then it will start with Docker image, and if you want to play with container, then Docker container. So Docker container ls will list you all the containers. Docker container rm will remove the container. So likewise. Okay, so understand this one. So as of now, I don't have any image present available over here. So let's pull Nginx. This Nginx image will get downloaded from the Docker Hub. Okay, let's pull it. As of now, just skip this part, the tag, the latest tag. Let's not go into that right now. Now you can see the status downloaded newer image for Nginx. Okay, so this is the image that got downloaded on our system. Let's see Docker image ls. Earlier the output was like this, there was no such image, but as we have downloaded a Nginx image, so that's where this is the repository, the thing but Nginx name of the image, and this is the ID of an image. It is randomly generated, means each and every image will have certain ID associated with that for uniquely definition. Okay, so this is the image ID which might change in future. Okay, let's say if nginx team have done certain changes in this image, then image id will change again. Okay, and this image was last updated 13 days before by the nginx team, and size of this image is 142 MB. Okay, so each and every image will have id associated with it for its uniqueness. That is one thing, and this will come directly from the docker hub. We don't have any control over it. Okay, now we have just saw how we can download an image at our end and how to see that image over the system. Now if I talk about a container, in that case docker container ls, we don't have any container created over here. How to create container? That command is also shown over the documentation. Docker run hyphen hyphen name, provide a name to a container, and then nginx. Okay, this is a kind of bigger command, but we will split this step by step, and we will just have the small command first. So run and name of the image. Okay, so docker container run name of the image will help us in creating a container from that image. Okay, run will always go ahead and create a container from image. So let's hit enter over here. Meanwhile, my command prompt is little bit busy over here, so I just need to log in with another terminal just to show you what's happening in the background. Docker container ps. Now this container got up and running 24 seconds ago. The container which I have just created with this command docker container run nginx. Okay, run is always going to create a container from image. So this container got created. This container will also get some random container ID for uniqueness, and this container got created from nginx image, and we have created this 24 seconds before, and status is up. Up means the container is up and running, and the name of the container will be randomly taken from the docker hub. Okay, as we haven't specified any name to a container right now, so this name will come randomly. Over here you are working on this terminal, and you can see uh, this terminal got busy, or this terminal is taken by this container, which is not a good process. I mean to say, like, this container should always run in the background. It should not take up my terminal. Okay, if it will run in the background, I can create a few more containers in the background and my terminal will be free. So I'll do the control C over here. If I do control C, the container will be in the stop condition, because I'm terminating this container related process over here. So if I show you docker container ls, there is no container right now present over here because I have stopped that container. In short, earlier that container was up and running, but now that container is not up. This docker container ls command will show you only the running containers, not the stopped container. And if you want to see all container, in that case just provide -a, which is going to show you all the container. All means जो container up होते हैं and जो container exited status में जाते हैं, all those containers it will be visible. So as soon as I have done the control C, the status of that container is into the exited one, because I have interrupted that process. That's where it came into the exited one, and this container is no longer useful for me. So I am going to just delete this container with the help of rm. Okay, rm के आगे there are two options. One is like you can provide the container id, or you can provide the name of that container. Both will work for us. Okay, so this time I'll provide the container id, and now you can see docker container ls-a, there is no container information available over here. It means this container got deleted successfully. So earlier I have executed docker container run nginx command to create a container from an nginx image, but that was created in the foreground. I want to create it into the background. So for that matter, what I have to do, I have to provide hyphen d. Hyphen d is nothing but a detach mode. So this is going to, the container will get created definitely, but in the background my terminal will be free. And some random names were coming earlier. I want a certain specific name, so you can provide hyphen hyphen name, let's say c1. This container name can be anything, but it should be unique with on this virtual machine. Okay, so I am creating a container again from the same image nginx, but this time I am providing a name to that container as a c1, and I'm creating that container in the background. Okay, so you can see I got my terminal back over here, and if I do docker container ls-a, this got created again 6 seconds before, and the name you can see over here is the c1 which we have provided. If you don't provide name, some random name will come to that container, assigned to that container. So this is how you can go ahead and create a container. Earlier when we have deleted a container, that time the container was into the exited status, so we have deleted with docker container rm and the id. If the container is up and running and you want to delete that container, so in that case, let's say I'll provide a name of that container rmc1. You will get an error message over here, because directly if any container is up and running, we cannot delete that. If you want to delete it, then stop the container before attempting removal or force remove. So two ways: one is like stop that container and then remove it, or second option, force remove. So there are two options to remove. So we will go ahead with first option, and then we will go ahead with second option later on. So how to stop container? Simple command, docker container stop, and name of the container or id of the container. So I will always provide the name because it's, I don't have to copy paste it. So once you stop this container c1, again that container will go into the exited status, and with the exited status, with the help of rm command, that container will get definitely deleted. Let's say if any container goes into the exited status and you want to bring that container again up and running, you can do that with start command. So exited is nothing but a stop, it is into the stop condition, and if you want to start it, just docker container start c1. Again the process will be start up and running within that container, and you can see this container was created 2 minutes before, but this is up and running from last 5 seconds. And this is how we can go ahead and start the container, stop the container, or sometimes let's say your container got hang, it's not responding properly, you have option to restart as well. Means it is going to start it, and sorry, it is going to stop the container first and start it later. So again it got restarted 3 seconds before. And if you want to force remove it, let's say rm से तो directly remove नहीं होगा because this is up and running. So if you want to force remove it, so f stands for force, and then this will get deleted automatically before, like without even stopping. But this is very a brutal action over here, a force removal. Best way to delete a container is like stop that container first and then delete it. So these are some basic commands that we are going to, that we will uh, execute a lot many times in the docker section, because like this docker image ls, container ls, create a container, delete a container. So we are going to do this lot many times within this entire docker series. So are you guys getting some points over here? Like commands तो याद नहीं रखना पड़ेगा, because like stop करने के लिए stop command, start के लिए start, restart के लिए restart, remove rm is for remove. So these commands are not that difficult to remember. So that's the one thing. And second thing is like, once you do the practical, definitely things will be much more easier to you guys as well. So whatever things we have discussed so far, is it clear over here? Okay, so this is like how to create a container and how to start, stop, all those things. Now we will see the actual use case of this, because कंटेनर के अंदर क्या होता है, we are not aware right now, right? How container look like when, अभी वर्चुअल मशीन के अंदर लॉगिन करने के बाद कैसे दिखता है, we know because this लर्निंग लिनक्स जो एक वर्चुअल मशीन मैंने बनाया है, so you know how it looks like. So you can execute any command within that and you can do anything within this virtual machine. Similarly, I told you that container is little bit similar to a virtual machine, only thing there is no operating system within that. So how container looks like when you log into that, we will see that. Okay, so as of now, if you do spelling mistake, so as of now there is no container, so let's create a container. Okay, so container got created over here. So if you want to log in, the way you logged into this virtual machine with the help of root @ IP address and you have provided a password, in the same way you can just log into this container. Okay, C1 container or ID, anything works over here. For that matter, execute is a command, exec is a command to log into the container, and name of the container as C1. Now let me explain this. Execute is to log into a container, and once we log into the container we want to interact to this container. मतलब container के अंदर I want to run ls command, cd command and certain extra commands I want to execute. So I want certain interactive terminal. Okay, IT stands for interactive terminal. We want to get, we want to interact with the container once we log in. So that's where we have to provide -it to interact once we log into that container. Name of the container and which command you want to execute within that container. Matlab, if you want to get a shell of that container, so bash is one of the shell which is provided by this nginx container. Okay, let's say if you want to run only the, I'll show you first. Execute c1. Let's say if I show you, if I execute this command, docker container execute, अभी मैंने -it नहीं provide किया, so that's where I'm again back to the virtual machine. I'm not inside to this container. So what is this output? This output is the container output. मतलब कंटेनर के अंदर ls चलाने के बाद जो भी फाइल्स एंड फोल्डर्स दिखते हैं, that is the output of that container. Internally, this command is going, this command is getting a prompt of that container c1 and execute ls command and it will show an output to us. If you want to go within that container, in that case execute -it, name of the container bash. Now you can see the terminal got changed over. Earlier it was root @ our virtual machine. Now it is root @ container ID. This is the container ID. This one you can see this ending with 65e. Same over here ending with 65e. Okay. Now we logged in within the container. You saw this output earlier, right? So if I do ls over here, the same output you will see over here, like docker entry point.d over here it is present. Then sorry, docker entry point.sh entry point.d, so these two files. So this command is not an interactive command, this is just to show you the list of files present within the container. But if you want to go within that container actually and look for the content or look for the things which are present within the container, then you have to provide an interactive terminal command to this and provide a shell to that. This is how you can go ahead and execute. We will execute lot many time because we will modify certain files within the container. Okay, I'll show you the use case of execute command in a moment. So for that matter, let me remove this container. Okay, now we don't have any container over here. Okay, we don't have any container, and we only have a single image, which is nothing but nginx image. Now if as I told you that nginx is nothing but a web server, so we should see certain output over the browser, right? Because as it is a web server, so it is mainly used to develop certain websites which we can see over the browser. So once we create a container from this, then definitely we should see the content over the browser. Okay, let's say uh, okay, so let's say certain scenario over here. Let's say this is my virtual machine, and okay, and within this virtual machine I have created a container over here. Okay, this is the nginx container c1, and the IP address of this virtual machine, let's say, what is the IP address? Let's say 1.1.1.1. Okay, this is the IP address, let's consider, of this virtual machine. And this nginx container, okay, by default nginx runs over the port 80. If you want to see the default port of nginx over here, you can just see, means nginx का जो process चलता है, that nginx process will always run over the port 80. So the process, that the nginx process that will execute within this container will run over the port 80. I mean, this is the configuration provided by the nginx image. We can change it definitely, but the default image will have the port 80 configured within that. Now if you want to access this container from the browser, so definitely we won't be able to access directly this container, because this container, let's say, is IP address set 2.2. Each and every container will have IP address. Okay, that is one more thing. So the IP address of this container is not visible over the browser, because this is created over the private network. Only the IP address of the virtual machine, okay, this IP address is understood by the browser, okay, not the container IP address, because container is getting created over the private network, so which will definitely will not be accessible over the browser. So only this IP address is visible to the browser. So we have to map the port of this virtual machine to the port of the container to do the things. I mean to say, if you want to access this container from the browser, then port mapping is the only option. How to do that? By just providing -p, let's say at, let's say 8180. What is the meaning of this -p 8180? Okay, the meaning is like, the first port it belongs to this virtual machine, second port it belongs to this container. It means if you access the like over the browser, if you say http 1.1.1.1 colon 81, okay, then internally this 81 is mapped to the port 80 of the container. So internally request will go directly to this container. So directly, so there is no way directly we can access to this container. This is the only way we have to follow it. Let me show you practically, so that things will be much more easier for you guys to understand. As of now we don't have any container. Let's go ahead and create a container. -p. This port can be anything because this is the server port, means 81 is, this port belongs to the host machine, the learning Linux. Okay, so this port can be any free port. Only thing you have to take care is like the last port, second port, because the second port is the port of the container. So इसके ऊपर आप 90 लिखोगे तो it will not work because container is running over the port 80 and we are mapping it to the port 90. So that's where things will not work. So if you want to map any this first port can be anything based on it is free or not. Second port must be the container port, which is the 80. Okay, so let's go ahead and create a container, and now you can see this port 81 is mapped to this port 80. So it means if you access this server or access this virtual machine over the port 81, automatically request will get redirected to the container. So let me show you practically this one. Where is my IP address of this? So this is the IP address of my virtual machine. So let's make use of it. :81. Internally, now you can see welcome to Nginx page we got. This is nothing but a standard page they have set within a Nginx container. Okay. So port mapping is only option to access a container from outside. Now if you want to change this page to something else, you can definitely do so by changing this page to the within the container. Okay, I mean to say, let's say that content, whatever content is visible, if you don't want that content to be available or visible over here, you want something else, you can definitely do so by just logging within that container, and अभी आपको पता भी होना चाहिए कि ये कंटेंट कौन से फाइल से आ रहा है. Okay, let's say if you are not aware of this nginx much and you want to know कि ये content कौन से फाइल से आ रहा है, directly you can google it like index.html page in nginx, or file location you can see, as I'm not sure about. So you can see by default nginx web server default location is at user share. This is one of the file system where this index.html file is present. मतलब ये जो content आपको दिख रहा है welcome to nginx, this is coming from index.html file present at this location. So let's go to this location. Over here we have this index.html. Let's try to open this content. You can see welcome to nginx, and then if you see this page, nginx web service successfully installed. So जो भी content यहाँ पे लिखा है, same content is visible over here. If you want to modify this content, you can definitely do so by just overwriting this file as we are, let's say, learning docker. So I have just written this index.html content, means overwritten that content. Okay, so पहले तो content ऐसा दिख रहा था. I have just modified the content to we are learning docker, and if you just refresh this page, you will see this we are learning docker. जो भी आप लिखोगे index.html के अंदर, you will get to see the same content over the browser over here. This is the proof, miss, like you can see this is the full proof that this URL is getting redirected to the container. Maybe this seems little bit tricky, but just wanted to know like how much you understood about this port mapping. If I just stop this container, or let's say if I just modify the content again, let's say docker 112233 something, and if I just refresh this page, I will get whatever the content I have added, and you guys also will get the same content. And if I just delete this container, then definitely this page will not work. You can see this page is loading and loading, and this site cannot be reached because now we have deleted a container, so there is no such uh, port forwarding is available over here. So you can see this deleting a container is very easy. It's like within a fraction of second the container will get created, within a fraction of second it will get deleted, start, stop. All those things are very quick in case of container, and if you want to do the same thing in virtual machine, definitely it will take a lot of time, which we want to avoid. So whatever things we have seen in case of the difference between the virtual machine and container, maybe you guys come to know now that how quick a Docker is and how easy to host a website within the Docker. You just have to modify this index.html according to your website content, and it will be very easy to launch your website over that URL. Okay, that's all from my end for today's section, because we have seen this was the first practical section of the Docker, and we have seen lot many interesting commands over here. So I hope you guys understood everything about it, and just try to do practice at your end to get more out of it. All the commands and things related to the Docker are already shared over the this link, sorry, GitHub link. Okay, I think I haven't shared this to you guys till now. So you'll get to see all those commands related to the container and images. There are few more commands which we need to explore. So definitely we will resume these commands tomorrow again. Okay, so let's wrap it up. Any questions so far? Okay, I hope you understood about all the commands that we have explored today. So if any doubt, just raise all your questions definitely without any hesitation. Okay. So thank you so much for joining today. See you tomorrow. Thank you so much. Bye bye.